Alrighty, boys and girls, this is Chapter 4, Section 4, Parallel and Perpendicular Lines. First thing we're going to talk about parallel lines, and there's the symbol for it. Parallel lines are lines that are in the same plane and they do not intersect. Remember, lines go on forever in either direction and they will never intersect. They also have the same exact slope. They are increasing or decreasing at the same exact rate, which is why they never intersect. Let's take a look at an example on what you would see on a test or a quiz about this. Okay, so here's an example question. Write an equation in slope-intercept form of a line that passes through -3, 5, and is parallel to y equals 2x minus 4. So, in other words, we want a line that's going to go through -3, 5, and we want the slope of this line. We know from looking here, this is y equals mx plus b format, so the slope here is 2. We want this slope of this new line to be 2. This is what we got from the question. Now, there are many different ways that you can solve this. You could plug this into y equals mx plus b format, solve for your b, and then rewrite the problem. But I'm going to show you a different way. That's what we did a couple sections ago. I'm going to show you a different way. First, let's start out with point-slope form. Y minus y1 equals slope times the difference of x and x1. Now what we're going to do is we are going to plug in the points, or plug in the points for this coordinate. We've got y minus, our y value is 5. Slope, we want the slope to be 2. X minus, and our x1 value is -3. Don't forget that negative sign. Now we can clean this up. Minus a negative, same thing as addition. So we have y minus 5 equals 2 times x plus 3. And now let's use distributive property to get this in a proper slope-intercept form. Y minus 5 equals 2 times x is 2x. Right here, signs are the same, so this is plus. 2 times 3 is 6. Now, we need to bring this minus 5, we need to bring that over there, so we're going to add 5 to both sides. This is going to cancel. We have y equals 2x plus 11. Now we have the equation of the line in proper slope-intercept form. Now, let's try another one. Same exact directions, except for this time we're going to go through 4, -1 and parallel to y equals 1/4 x plus 7. Now, if you want to try this on your own, pause the video, press play when you think you have the answer. If you want to just watch along, that's fine too. So again, we're going to start with point-slope form. Y minus y1 equals slope times the difference of x and x1. Now we're going to fill in our values here. We have y minus, and our y value is -1. And we have our slope from this equation right here, y equals mx plus b, there's the m, 1/4. X minus, our x1 is going to be 4. Now, let's clean this up. Minus a negative is plus, so we have y plus 1 equals 1/4 x minus 4. Now we need distributive property. So, 1/4 times x shouldn't be trouble for anyone at all. Some people might get confused here on what to do if you haven't worked with fractions for a while. So let's take a look at this. We have 1/4 times 4. Since these signs are different, I'll go ahead and put the minus right here. This way we can just deal with the multiplication itself. Remember, you can make any whole number into a fraction by putting it over 1. Now we just multiply straight across. 1 times 4 is 4. 4 times 1 is 4. Same number on numerator denominator equals 1 whole. So this becomes -1 here. Now, let's get rid of this plus 1 to get this in proper slope-intercept form. Subtract 1 on both sides. This cancels. Y equals 1/4 x minus 2. And there we have it. Hopefully you did well. So now let's talk about perpendicular lines. Perpendicular lines. These lines intersect. And not only do they intersect, but they intersect at a right angle. Right angle that's 90 degrees. The slope of perpendicular lines is actually the opposite reciprocal. So, for example, let's suppose I had a slope that was equal to 4. The perpendicular slope would be the opposite, meaning negative versus positive, so we're going to make this negative, and reciprocal. So remember, to make this into a fraction, I could put this over 1. Reciprocal is that fraction flipped, so it would be 1/4. Another example, suppose I had a slope of negative 1/3. The perpendicular slope to that would be the opposite, positive, and reciprocal, 3/1, which equals 3 whole. So let's take a look at an example of writing an equation in slope-intercept form when we have perpendicular lines. Okay, so let's write an equation in slope-intercept form for a line that passes through point -4, 6 and is perpendicular to 2x plus 3y equals 12. So what we're going to do is we're going to start out with the original equation, 2x plus 3y equals 12. And we're going to rewrite this in slope-intercept form, so that way we can easily identify the slope. So first thing is we need to get this x over here, so we're going to take away 2 x's on both sides. This cancels, we have 3y equals, now remember for slope-intercept form it's y equals mx plus b, so we're actually going to lead with this negative 2x, then put the 12 there. Since there's nothing preceding the 12, we know this is positive, so we write plus 12. Now, we want to get rid of this coefficient here, this 3. So watch what I can do. I'm going to divide the left side of the equation by 3 and the right side of the equation by 3. Got to do the whole thing. You can't just pick and choose parts. Right here, this cancels. We're left with y. Now here, I can split this 3 up onto each term. It'll make my life easier. Watch. I have negative 2/3 x. I put the 3 there. And I have to put it here too. Plus 12/3. Now we can clean this up a bit. 12 divided by 3 is 4. Hopefully you easily saw that. So we have 2/3 x plus 4. So now we know the original slope is equal to negative 2/3. Well, if the original slope is negative 2/3, then the perpendicular slope is going to be the opposite reciprocal. So it's going to be positive 3/2. So now we're going to use this perpendicular slope along with the point right here, -4, 6, and we're going to try and get the equation of a line that passes through this with this slope. Let's take a look. So, just like last time, we are going to start with point slope form. Y minus y1 equals m times x minus x1. And we're going to fill in what we know. Y minus, our y1 value is 6, equals our new perpendicular slope, 3/2, x minus, and our x1 value is -4. Now, let's try and clean this up a bit. Y minus 6 equals 3/2, x plus 4. And now I'm going to distribute this 3/2. We have y minus 6 equals 3/2 x plus, and for those of you concerned about this, let's take a look. We have 3/2 times 4. I make this 4 into a fraction by putting it over 1. 3 times 4 is 12. 2 times 1 is 2. And 12 divided by 2 is 6. So it's going to be plus 6. Now, to finish this up, I'm going to add 6 to both sides to get rid of this. I'm left with y equals 3/2 x, and 6 plus 6 is 12. So here we have the formula, or the equation, for a line that passes through point -4, 6, and was perpendicular to our original line, having a slope of 3/2. Alright, hopefully you understand all this well, and I will see you in class.